Hello, my name is Gabriel Gillott. My project is eUR-443. I know this isn't really the type of video that judges are looking for. However, I realized after submitting my project that due to the sensitive nature of the data involved, which is Cobb County police reports, I wouldn't be able to go through my project in the level of detail I would like. So instead, I have a Google Colab Jupyter notebook that goes through the theory behind the principles that I'm using. So the idea is to use gzip, which is a compression algorithm, with KNN in order to classify data. In this notebook, I'm doing sentiment analysis. The reason that this technique would work is that gzip, which is based on the deflate algorithm, attempts to mitigate as much redundancy in data as possible. And the idea is that text with similar categories or with similar sentiments would have a lot of redundancy. So what we do is we compress them. We take the length of the compression, and then we create a normalized compression distance, which is done in this function here. And this is done pairwise. So this is every piece of data in the data set. This will happen with every other one. So each data point winds up being represented by a vector comprised of 401 normalized compression distances. And this is the most time-intensive part of this process. In a relative sense, the KNN classification is fairly quick. With this relatively naive approach, I was able to attain an accuracy of 70%, which, while it certainly isn't beating BERT, it was pretty amazing to me in terms of its ability to capture the nuance of sentiment. However, it does seem that the algorithm tends to perform best when it has a lot of samples, but this introduces the problem of the slow nature of the NCD algorithm. So I attempted to compensate for this by introducing threading, which certainly helped in terms of the amount of time that it took. And with using many more data samples, I was able to achieve an accuracy of 75, 76%. This was pretty astounding to me. And I wound up doing a little bit more exploring in terms of things like TSNE. And yeah, that's pretty much it. I just wanted to show it. And the link to this notebook, if you're interested in checking it out, is on the poster. But thank you for watching.